So hello guys, welcome to the today's LeetCode problem. Name as partition labels, which is marked as a medium level, but I would say it is a easy level problem if you clearly observe the problem description and the test cases. Okay, so what is the problem statement is saying that we are given a string yes, and we have to partition the string into as many parts as possible, but there is a case. But is that so that each letter appears in at most one part, means each character should be appear or should be part of the only one partition. For example, if I have a string a b a c, then if I want to do partition, I have to do the partition only like this, because if this a is belonging to the first partition, then this a should be belonging to the same partition. I can't do the partition like this, a comma b a comma c, because this a are not belonging to the same partition, so this is the invalid one, so this is valid one. And same what they have given here for the string abacc, this is valid one, because if you see same character belonging to the same partition, but this is not valid one. Why? Because b is here, b is here, so invalid. Same for this one, a is here as well, here as well, invalid one. Correct? Note that partition is done, so after concatenating all parts in order, the resultant should be the string. Means if you concatenate this, so ABAC is giving me the original one. This is what it is saying, that we have to return list of integer representing the size of these parts. Make sense? Now let's understand with the test case. So this is the test case given here. If you see, this is my A, correct? So what is our greedy approach over here? If this is my A, and if I starting from 0, means first partition, correct? So I have to make sure that all A should be included in that partition. So what I will do, I will check where is the ending of this A. Here is A, here is A, here is A, here is A. No A is there. It means I have to take, this is for sure, I have to take this much part of the string, because my all A's I have to include, correct? Now let's see what are the other characters are there other than A. B is here, so I have to make sure I have to include all B's now, correct? So what is B here? Here is B, here is B. Okay, no B is there beyond that, correct? Makes sense. So A is done, B is done. Now let's see for C. So end of C is here, C is here, no C is there. It means that I have to include this part of the string, correct? So what is the size of this part? The size of this part is a 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why the first element is a 9 in a result, correct? Makes sense. Now let's try to do the another partition called as a second partition. So second partition, first element is a D now. So I have to make sure I have to include all D's, correct? So end of the D is here, I would see, correct? So I am 100% sure that I have to include this string. Now let's see for other remaining characters. For this E, where is the end? Here is the end, so it means I have to extend this partition till here. For this F, where is the end? For this F, there is no end, so here is the end only, so makes sense. For E, we have seen. For G, it is the end only. For D, we have already seen. For E, we have already seen. It means that the size of the second partition would be 1, 2, 3, 4, 5, 6, 7. That's why the second element is 7. Now our third partition, starting at H. So I have to make sure I have to end first at H. So this is my H here. So it means that this is my fixed partition. Now let's see for other. For I, okay, I is here, so I have to extend it till here. For J, it is here, so I have to extend it here. It means my third partition has been extended by 2 times, correct? Because I have to make sure that I am including the other characters as well in a same partition only. Makes sense? Now let's calculate the size. 1, 2, 3, 4, 5, 6, 7, 8. That's how output is 8. Correct? So this was the test case. And if you see what we have done in this case. What we have done. First, what is the step? Take first char. Correct. And mark till end of that char. Okay. Mark till end of that char. Second, extend partition for other chars. which is a part of same partition. So these were our observations so far as of now. So same thing we did here, right? For H it was still here only, correct, but for I and J we extended it because these are also the part of this partition. So I have to make sure that these should not be the other part of the other partition. So that's why I have included I here. So this is what it is saying. So my intuition in this problem is that, okay, what we can do, we can create a dictionary, okay, hash map. We can have the hash map of ends. Okay, so if I ask my hash map A, give me the end of A, then it will return me the index of the A where last A is present. If I ask hash map, give me the index of I, so it will give me the last index of I in the string. So this is what I will build, and let's try to solve this with the help of simple test case. So here is only one. So what I will do, I will take another example, S equal to A B A C C. This example I would take, correct. Now my hash map would look like this. My A 0 1 2 3 4, my A is ending at 2 index, makes sense. My B is ending at 1 index only. My C is ending at 4 index, correct. Now what I will do, I will try to iterate over this string. It means I will have the index variable which is initially at 0. I will have the size variable which will tell me the size of the current partition which will initially 0, correct. Now I am here. Initially I am here, right? Initially I am here, that is 0th index. My index is here. Now I will say, okay, I have to run my loop or my partition till end of this character. So I will ask hash map, hey, tell me what is the end of this character. He is saying 2. So it means that I have to run my index till 2, correct. The upper loop will be running till end, correct. This while loop would be running this then. Again there will be the another while loop which will be telling me the run this index till this 2 and increase the size. So I will just say size plus plus, makes sense. And now I will move to the next index, that is index plus plus. From here to here I will make. Now again I will ask hash map, hey, tell me the end of this. So end is 1. Previous end was, okay, if I maintain the end variable, previous end was 2. Now I got a new end, that is the 1 only. But I will say no, 2 is bigger, so I will not update it. Okay, I will come here. Now it is, I will again ask for this hash map, hey, what is the end? Again 2, same. So I will run this while loop less than equal to till 2. It means that my size has been incremented by 3 times. 1 from here, 1 2 3. So I will just append into my result 3, correct. Now I will jump over here. Again now I will have new end now. What is end? That is a 4. So now my end is a 4. I am at a 3rd index, correct. So I will increment my size by 1. I will go here. I will again ask hash map, what is the end of this character, because I don't know it is the same character. So it will say 4. It's fine. So I will increment my size by 2 and I will append it into the result. And I will be exhausted with my input string because this condition will become fail now. Index is 4, which is not less than the length. What is the length? So here I am incrementing index, so it will become 5. So 5 is less than 5. So I will stop my iterations over here. Simple, right? So what is our approach here? First approach is a build hash map for last index of each character. So in a hash map I will store all characters, but value would be the last occurrence of that character in my string. Second, iterate over a string and put 3 variables. End will tell me till what index I should run my inner while loop. Size would be incrementing, which will tell me the size of partition, correct. And my inner loop will run, index still will run less than equal to end. This will be my inner loop. This is our intuition, right? And in this while loop only I would be incrementing my size. I would be incrementing by index. And once I am done with this while loop, I will just say result. If I have the result dictionary, I will just say list result.append size. That's it. And before this while loop, I would be every time initializing size with equal to 0 only. End would equal to the hash map of that character. current character basically, s of index. And I said, right, at every step I would be checking whether I have got new end or not. It means end equal to max of end and hash map of current character, whatever the indexing I am incrementing. So s of index, because it might be the case I would get the new end. Same for in this case, right, where for this h my end was this, but for the inner character I got new end. For this j I got new end, correct? So I have to make sure I will be updating my end. So this was the intention. So code for this problem is simple, and this is a big of n solution only, because we are not, even though we have two while loops, but we are making sure we are running iterating over the string only once. So this is my code. What I have done, I have taken the dictionary or hash map in a Python, end of character, which would be telling me the last occurrence of the character, and I have just iterated over the string, and I have just put the last character. I am just appending. So for example, a b a c c, so I will just say put initially 0, because 0 1 2 3 4. I come here, I will put b equal to 1. I came here, I will put a equal to 2. I am replacing the existing values. My bad. Correct. Then for C I would just put a 4. Correct. So this is my hash map looking like now. So end of char is this one. Size of partition is my result array. N is the length of the string. Index initially 0. So what I am doing, I am running my while loop from 0 to end of the string. Then I am taking the current end from the end of char. I am taking the size, and as I said, right, inner loop will run for index less than equal to this end, and index I have to check I am not going beyond the string. So this is just extra part, but this will not be the case anytime, so you can keep only this one, it makes sense as well. Then I am updating my current end if there is new end or not. Correct. So I already told you, right, here we have to check whether we are getting the new end or not. Correct. So this is what I am checking here. Then I am incrementing the size, I am incrementing the index. Once I am stopped, once I am got the complete partition, I am appending the size, and this loop will run till the end of the string, and finally I am returning the array. So time complexity would be the big of n, even though we have two while loops. Why? Because this index is the same one, so I am making sure I am iterating only once, and the space would be the big of n, because in worst case we can have the sizes, each character is unique, so we will have the length equal to 6 only. So big of n in a worst case. So I hope you got this problem. See you in the next video. Thank you.